over the past week or so, we've been looking at polynomials, and we've been looking at long division of polynomials. Today, there is a different type of division that we can use that you might have heard of before, and it is called synthetic division. Okay? For some people, synthetic division, it's like, yes, I love synthetic division because you don't have to look at variables, and it's just numbers and adding numbers and multiplying numbers. I am going to tell you today, we will be using long division and synthetic division. And the reason why we cannot use just synthetic division is because the way that you probably learned synthetic division was if you have something in here, like x squared minus 4, and you had something out here, like x plus 2, you can do synthetic division with this. But if you had something instead, like x cubed minus 4, and x squared plus 2, you can do synthetic division like this, but we will never teach it to you because it requires a lot of little things that you have to remember, and people end up just making little mistakes instead of being able to solve it. So, just kind of as a general rule, if you have some kind of problem where on the outside there's some kind of x squared term or greater, you will most likely never be using synthetic division. Actually, I will tell you, you will not be using synthetic division. Okay? If you have something where there is just an x and then some kind of constant term, then you may use synthetic division. Okay? So, to kind of go over what synthetic division actually is, if we have this polynomial here, and we know that x equals 2 is one of its roots, and we want to factor it out so that we can find what other possible roots they could have, you would end up with a situation like this. So you can just set up all of your long division, and then we could technically long divide. But synthetic division looks like this. And if you can see right here, all it has is just 1, 2, 3, 4, 5 numbers instead of all of this stuff going on, right? Just 5 numbers. And so what we do when we're looking for synthetic division is we first start with our divisor. This is called our divisor, right? We start with our divisor and we say, okay, we want to look at our divisor and we want the x-intercept that would come out of our divisor. So if we have x minus 2, the x-intercept, or the 0 that you would get, would be x equals 2. So then we would put a positive 2 right here on the outside of our synthetic division. Then we create this kind of upside down dividing symbol because it kind of helps us divide this divisor from all of the numbers inside. And from here, what we then want to do is we want to look at each of our terms of our polynomial, and we want just the coefficients. So, for example, we have an x cubed. The coefficient of x cubed is 1. So we will just put a 1 here. The next digit is next term is 4x squared, which has a coefficient of 4, which is why we put a 4 here. And then the next term is a negative 5x. So we put a negative 5x here, and so on. Okay? Once we have this all set up, the first thing we want to do is we want to look at the first number inside in our dividend, and we want to just move it down so that it's outside of our box, outside of the dividing box. So we have a 1, and from this 1, we then want to take whatever result we get here and multiply it by our divisor. So we'll have 1 times 2 in this case. And 1 times 2 will give us 2, and we'll write the 2 inside the dividing box underneath our 4. From there, we're just going to say we have 4, we have a 2, add them together, you get 6. And then we're going to write 6 down here. So now we have a 1, we have a 6. From there, we're going to do the same process over and over again. So take our 6, multiply it by our divisor of 2. 6 times 2 is 12. Then we have negative 5 plus 12, which will give us 7. And then we do the same thing one last time. 7 times 2, we'll get 14. Then we have a negative 14 plus 14, and we'll get 0. Now we have 4 different numbers here, but what do these numbers mean? This last number here is our remainder. Okay? So, in a case like if we were doing long division, this would be where at the very end you get 0. This is equivalent. So these two things are the same thing. Okay? This is just our remainder term. And then each of the next numbers just go up 1 in terms of x exponential power. So this 7 is just our constant term. It's the first term, it's the constant term. I'll write that in a different color. And then our 6, we have to go up 1 in terms of x exponential terms. So that means that we have an x, but since there's a 6, that means that we have a coefficient of 6 in front of our x. And then before that, we have a term that starts with a 1, and we know it has to be an increase in power, so it's going to be x squared with a coefficient of 1. And if you check over here, they give you the answer. And so that's what we end up getting. Now, if here, instead of this x minus 2, instead this had been an x plus 2, what would we have changed about our divisor over here? This would then be a negative because we are looking for the x-intercept of the divisor, not just looking at the number. Okay. Now, one other case. If, for instance, I went back to this example of x squared minus 4 divided by x plus 2, and I wanted to do the synthetic division for this, I would say, okay, x plus 2 is going to become a minus 2 on the outside. Draw my upside down dividing box. And then in here I have an x squared, so that's going to be a 1. And then I have a minus 4, so that's just a minus 4, right? Is x plus 2 a factor of x squared minus 4? Yes, it is. So I should, theoretically, get a 0 out of this here, right? So if I do this process again, I get a 1 here, multiplied by negative 2. Negative 2 minus 4 is negative 6. I got a remainder. Franny, why do you think this didn't work?
Because you didn't include it with the 0 sign.
Yeah. So remember yesterday how I said I would suggest that if you have something with a missing term inside your dividend here, that you just continue to add a 0x component and then continue on with whatever else you have so you can keep track of your place. During synthetic division, this is not a suggestion, it is a must. Okay? So here, instead of having this negative 4 and this negative 2, we will have a 0, and then we'll have our negative 4. And then, if we replace it like this, we'll have a 1 times a negative 2, which will give us a negative 2. And we'll have a negative 2 down here. And then if we multiply that, we'll have a positive 4, and we will get the remainder of 0 that we expect. Okay? Today, we are doing an activity in class. This activity will help you practice both long division and synthetic division. This activity requires some movement, but first and foremost, it requires you having a partner. So, can you take 20 seconds and get with a partner? I believe we have an odd number of people today, so could you join a group of your choosing? Okay? Join a group of your choosing, and it'll be a group of 3. And then, can you work with Remind me of your name again.
Will.
Will, can you work with Will today?
I would love to.
Awesome. Thanks, Ryan. Okay. So, because this will be an in-class activity, I will not be recording for the in-class activity because you have to be here to experience it. But it's basically just a lot of long division and synthetic division practice, right? So, before we do the activity, because I just kind of want to finish the recording out, if you could quickly get to today's homework, I will tell you which 3 problems you should do. Or maybe it's 4 problems, but I believe it is 3. I should also probably get there. So, if today is the 8th, so if you go into today's homework, actually, you know what? I believe today's homework is in yesterday's day, not today's day, because we are learning synthetic division today instead of yesterday. So if you could actually go back into that folder and pull that one out, then it should start with this, which is what you started doing for homework yesterday, right? So what I would like to do for homework today is I would like to give you some synthetic division practice. So can you please do the first 2 and not the last one? And then you already did one of these for homework yesterday. So could you go to this last page here? Oops. And could you just do the middle one? You don't have to do the first or the last ones. Right? So that is all we are doing for homework today, for this weekend. And with that done, we are going to start our activity, so I'm going to end the recording here.